Most people think they know China's energy story. It's all about solar panels and electric cars, right? For years, that's been the headline. A story of scale, of factories, of overwhelming the world with mass-produced hardware. But that story, the one everyone is telling, is already years out of date. The real story isn't what China is building. It's what China is becoming. Behind the scenes, a much bigger, more profound transformation is unfolding. It's a quiet industrial revolution, a coordinated national mission to achieve something no country has ever attempted, to master not just one or two, but the entire next-generation energy stack all at once. What the world sees as individual breakthroughs, a new type of reactor here, a green fuel plant there, is actually a single coherent strategy, a plan to build from the ground up the whole post-fossil fuel world, and it's happening faster than anyone thinks. To understand this strategy, you have to start with China's greatest weakness, its dependence on foreign oil. With over 70% of its oil imported, a staggering vulnerability for a global superpower, the flow of tankers through the world's narrow straits has been Beijing's Achilles heel for decades. Everyone assumes the answer is just more electric cars and solar panels. But that's not the answer to the hardest questions. How do you fly a plane without jet fuel? How do you make steel, cement, and fertilizer without fossil fuels? How do you power a megacity when the sun isn't shining and the wind isn't blowing? China is pouring hundreds of billions of dollars into answering those questions, not in the laboratory, but at industrial scale. This isn't about hypotheticals. This is about building the future today. Let's start with the biggest challenge: liquid fuels. Aviation, shipping, heavy industry, these are the sectors that can't just plug into a wall. They run the global economy, and they run on dense, liquid hydrocarbons. For China, this is not just an emissions problem. It's a national security imperative. An economy held hostage by oil prices and shipping lanes isn't a secure economy. So, what's the solution? For years, the world has been buzzing about a radical idea: making fuel from thin air. The concept is called power to liquids, or e-fuels. You take renewable electricity, use it to split water into hydrogen, capture carbon dioxide, and then, using advanced catalysts, combine them to create synthetic, carbon-neutral liquid fuels, including jet fuel. While a global race is on to perfect this technology, with serious projects in Europe and the Americas, China is pushing aggressively to move from theory to reality. The Dalian Institute of Chemical Physics, for example, developed a groundbreaking process to convert CO2 directly into gasoline. This isn't just a beaker in a lab, it's a 1,000-ton per year demonstration plant, proving the chemical engineering at a pilot scale. Meanwhile, China is also launching national pilot projects for sustainable aviation fuel, SAF. While large-scale production is still in its early days, the National Energy Administration has directed provinces to use their surplus renewable energy to build new industrial bases for green fuels. Think about what that means. If you can create liquid fuel using domestic renewable electricity, you are no longer dependent on foreign oil. You have just started to solve one of the most wicked geopolitical problems of the last century. China sees this not just as an energy technology, but as a tool for strategic independence. They are methodically moving it from the lab to pilot projects and towards industrial scale. But liquid hydrocarbons are just one piece of the puzzle. What about the fundamental building blocks of modern civilization? The fertilizers that feed the world and the chemicals that form countless industrial products. Most are made using ammonia. And for a century, making ammonia has meant burning massive amounts of natural gas or coal, releasing huge amounts of CO2. China's solution? Green ammonia. This is ammonia produced not from fossil fuels, but from renewable electricity, water, and nitrogen pulled from the air. It's a clean, green molecule that can decarbonize agriculture and industry. But it can also do something more. Green ammonia is a fantastic way to store and transport energy. It's a dense, stable liquid that can be shipped around the world, essentially bottling sunshine and wind from a desert and using it in a factory or a ship on the other side of the planet. And China is moving aggressively to lead this space. While other massive projects are underway, like the NEOM project in Saudi Arabia, China is bringing huge facilities online. In Chifeng, Inner Mongolia, a company called Envision has launched what it calls the world's largest green hydrogen and ammonia plant. The first phase is already operational, with a capacity of 320,000 tons of green ammonia per year, and exports are planned. The entire facility is powered by its own dedicated off-grid system of wind and solar. The CEO of Envision has called green ammonia the new oil. He pointed out that storing a given amount of energy in ammonia is vastly cheaper than storing it in batteries. This is about creating a cost-effective, transportable green fuel. The project has already attracted a long-term purchase agreement from Japan's Marubeni Corporation, signaling huge international commercial interest. By 2028, there are plans for the Chifeng project to scale up production significantly. This isn't just about making a single product. It's about creating a replicable blueprint for clean industrial hubs. China isn't just generating green energy. It's industrializing the production of the green molecules that could power the future global economy. Okay, so they have a plan for green fuels. But all of this, the e-fuels, the green ammonia, depends on a constant, massive supply of cheap, clean electricity. And that brings us to the oldest problem with renewables: intermittency. The sun doesn't always shine and the wind doesn't always blow. For decades, the answer has been lithium-ion batteries, and China makes a huge portion of the world's supply. But batteries are best for short-term storage, for a few hours. What happens when you have a week of cloudy, windless weather? To truly run a country on renewables, you need long-duration energy storage. And China is building a whole portfolio of answers. Near the city of Golmud, China has activated a massive 100-megawatt molten salt solar power plant that can store energy for hours. But they're also pushing into even more advanced technologies. One of the most exciting is liquid air energy storage, or LAES. The concept is brilliantly simple physics. When you have excess electricity, you use it to power a massive refrigeration system that cools air until it turns into a liquid. This liquid air is then stored in giant insulated tanks. When you need the power back, you let the liquid air warm up. As it turns back into a gas, it expands over 700 times in volume, rushing with immense force through a turbine to generate electricity. This isn't a battery in the chemical sense. It's a giant mechanical battery made of steel, tanks, and air. And a 100 megawatts/400 megawatt hours LAES plant in Yunnan is considered a leading global demonstration. This is not a lab prototype. It's a commercial-scale plant connected to the grid, tackling a real-world problem. This is just one of many solutions they are deploying. China is also a leader in compressed air energy storage, CAES, using vast underground caverns to store compressed air. It's a portfolio approach, testing and deploying multiple long-duration storage technologies at once. They are systematically attacking the single biggest weakness of renewable energy. If you're finding this deep dive into China's energy strategy as fascinating as I do, consider subscribing. We go beyond the headlines to connect the dots on the technologies that are about to change our world. We have a lot more to cover. But what if you could have carbon-free power that runs 24/7 with no need for storage at all? For decades, that was the promise of nuclear power, a promise that stalled in much of the world due to concerns about cost, safety, and waste. While the West was debating, China was building. But it wasn't just building more of the same old reactors. It was systematically mastering the next generation of nuclear technology. Take the Shidao Bay nuclear power plant. It's home to the world's first fourth-generation high-temperature gas-cooled reactor, HTR-PM, to enter commercial operation. Instead of traditional fuel rods that can melt down, this reactor uses thousands of billiard ball-sized pebbles of uranium fuel. Its design has inherent safety features, meaning that even in a complete loss of power and coolant, the physics of the reactor are designed to shut it down and cool it naturally. This isn't a theory, it's an operational power plant. But that's not all. In Hainan province, the Linglong 1 is on track to begin commercial operation in the first half of 2026. Billed as the world's first commercial onshore small modular reactor, or SMR, it represents a new model, smaller, factory-built, and easier to deploy. Its design was the first SMR globally to pass the International Atomic Energy Agency's rigorous safety review process back in 2016. China now has around 60 reactors in operation and about 36 under construction, the largest number of reactors being built in the world. The country has approved dozens of new units in just the last few years and is rapidly industrializing advanced nuclear power, creating standardized, exportable technology just as it did with solar panels and high-speed rail. All of these technologies, synthetic fuels, green ammonia, advanced storage, next-gen nuclear, are about mastering energy on Earth. But China's ambition goes even further. It's investing seriously in the ultimate energy source, a star on Earth, nuclear fusion. For decades, fusion has been the holy grail of energy research, always 30 years away. It's the power of the sun harnessed in a magnetic bottle. In Hefei, China operates the Experimental Advanced Superconducting Tokamak, or EAST. They call it their artificial sun. This is not just a token research project. EAST has been systematically breaking world records. In early 2025, it achieved a sustained high-performance plasma reaction for 1,066 seconds. That's over 17 minutes. This shattered the previous world record, also set by EAST. Researchers are also pushing the boundaries of plasma physics, working to overcome long-standing barriers to make fusion more efficient. Let's be clear. Commercial fusion power is still a long way off, but China is playing the long game. It has established a formal three-step strategy for nuclear energy development, from thermal reactors to fast reactors, and ultimately to fusion reactors. They are not just funding university labs, they are treating fusion as the final destination on their national energy roadmap, and they are taking concrete engineering steps to get there. So let's step back and look at the big picture. This was never just about solar panels. It's a systemic plan to create liquid fuel from air. It's building massive green ammonia hubs to create a new oil. It's pioneering new forms of energy storage in the desert to make renewables available 24/7. It's commercializing pebble-bed nuclear reactors with inherently safe designs. And it's methodically breaking records on the path to fusion